All right, hi everyone. My name is Decker. Now we'll be discussing edema as it relates to bulk flow. Just as a reminder, as hydrostatic pressure, blood pressure, is higher than colloid osmotic pressure, we have net filtration of fluid out of the capillary into the surrounding interstitial fluid. And when hydrostatic pressure is less than colloid osmotic pressure, we have net absorption of fluid from the interstitial fluid back into the capillary. This interstitial fluid we're also going to be referring to as lymph. Edema is the swelling of tissue just from a buildup of fluid in the interstitial space, as well as buildup of fluid in lymph. There are a dozen different ways for edema to occur. I'm just going to be showing you 3 examples that use predominantly terms that we already know. First example is from an increase in hydrostatic pressure, specifically at the venous end. This can happen as blood in the venous end stops fighting against gravity. You're sitting down for too long, blood is pooling. It's not going against gravity. It's pooling, it's increasing in volume, increasing in pressure. The more fluid in the vessel, the harder it's pushing against the vessel. That's going to increase end hydrostatic pressure, decreasing the amount of absorption that takes place at the venous end relative to the amount of filtration that took place at the arterial end. This edema is just swelling around the capillary. It's following the pattern of some combination of increasing filtration and limiting absorption. The next possible reason is decreased colloid osmotic pressure. This isn't a strategy the body uses, it's more a disease that we have to deal with. Colloid osmotic pressure is, again, the concentration of proteins in the blood. The main contributor to colloid osmotic pressure is a protein called albumin. It's relatively large. It's produced by the liver. During hepatic failure, it can be underproduced, lowering the concentration of protein in the blood. In this example, I have it down from 25 to 21. That's an arbitrary number. It's just less than the example that we already know. As colloid osmotic pressure decreases, hydrostatic pressure is now higher than it for longer and less than it for less time, increasing net filtration, bringing fluid out of the capillary into the surrounding lymph and interstitial fluid, and decreasing net absorption, which is bringing less back in. Again, some combination of extra filtration, less absorption. And then the third example, lymphatic blockage. This is some blockage in the lymph preventing net absorption from occurring, preventing some fraction of absorption. So here we're reducing the amount of absorption. Filtration stayed the same, but because we're taking less back into the capillary, it's like more had flown out. So again, some combination of increasing filtration or leaving it as the same and just preventing absorption. Doing these is how we get a buildup of fluid around the capillary in the surrounding tissue. Then, because I had to look at it again, so do you. Here are the swollen baby legs from lecture. All right, that was fun. Good luck on the whatever exam is next.